Hi guys, it's me, Miss Stone here to talk about mass to liter conversions and mass to atom conversions, okay? So you should get your note slide out and ready to go so we can set you up with some examples, okay? So we should be on slide 13 for our mass to liter conversions. So when we're going from mass to liters, this is the formula setup that we're going to use. We're going to start with the grams of what we're given over 1, go into the 1 mole of what we're given over the molar mass, our mole ratio, and then the new step that we're adding is this 22.4. Let me get my laser. I think this is it. Oh yeah, my highlighter. My 22.4 liters of what I'm trying to find over my 1 mole of what I have to find. Okay, so this right here is the new step. So my example, how many liters of water are produced if you start with 4.12 grams of hydrogen gas? So I'm going to plug in all my information. So when we went from mass to mass, the first 3 fractions are the same. The only thing that changed is this 22.4 liters of water over 1 mole of water, okay? So to get this math, remember, multiply everything on the top, multiply everything on the bottom, and then you divide, okay? So just making sure I'm in the right place. Yes. We're going to work through this together, all right? So we're still working with the same reaction. Tin plus hydrofluoric acid or hydrogen fluoride yields tin 2 fluoride and hydrogen gas, okay? So the question here is how many liters of hydrogen gas are formed if you start with 90.3 grams of tin? So as always, I don't know if I can, oh, here we go. We're going to start with what we're given and what we have to find. Okay, so we're given 90.3 grams of tin. And we have to find the liters of H2. Oh. Okay. So, oh, thank gosh, I can use the math type. So now that I know what I'm given and what I have to find, I'm going to use this math type add-on. And I need to erase this, but that's okay. Or I'll just move my math type over. So once it loads, there's a lot going on my computer right now. Oh, it'll work. This is good. Once this loads, we're ready to go. So remember, we always start with what we're given over 1. So we're going to have 90.3 grams of tin over 1. And it needs a minute. It's thinking. Then we're immediately going to go into 1 mole of what we're given. So 1 mole of tin over the molar mass of tin. Now tin's an element, so we're going to use the atomic mass. So we're going to have 118.71 grams of tin on the bottom. My next conversion factor will be my mole ratio. So I'm going to have moles of what I'm trying to find on the top, which will be moles of H2. And then I'm going to have moles of what I was given on the bottom. So I'm going to have moles of tin on the bottom. Nothing here is new. We've been doing this for a few weeks now, okay? When we do this part, you should hear in your head, where do we get the numbers for our mole ratio from? The balanced equation. So the coefficient that is in front of H2 is 1. So it's going to be 1 mole of H2. The coefficient that is in front of tin is also 1. So we're going to have 1 mole of tin. So we have a 1-to-1 mole ratio. This right here is the new part. Okay, so this is where we're going to use this new conversion factor of 22.4 liters of gas for every 1 mole of gas at STP. STP means standard temperature and pressure, okay? STP, 22.4 liters for every 1 mole. Okay, since I'm trying to find liters of H2 will go on the top. And we're going to have 1 mole of H2 on the bottom. Again, when we have liters with moles, it's 22.4. And you're probably like, Miss Stone, where is that 22.4 coming from? That is just, it's a gas constant. It is a molar volume constant, okay? So whenever you have 1 mole of gas at STP, it takes up 22.4 liters of space, all right? So it's kind of like how when we have atoms, we use Avogadro's number. So when we have liters, we use 22.4. So now to do my math, and I'll break it down for you guys like I have been, I'm going to do 90.3 times 1 times 1 times 22.4. And that's going to get me 2,022.72. And on the bottom, we have 118.71 because we have 118.71 times 3 ones. Anything times 1 is itself. So now we're going to take our top number, our 2,022.72, and divide it by our 118.71. And we're going to get hold on, Miss Stone is thinking. Miss Stone's calculating. 118. That gives us 17.04. And our final unit is going to be liters of H2. So once I'm done with that, I hit insert, and then the math type is going to put it into my PowerPoint. Sorry, my mask is making my nose itch. And then we can drag that over here if it works. And bam, we have our example done. Okay? So that's for liters in mass. We also need to talk about mass to atoms. Okay? So that's going to be our next set of notes. And they're really brief, so I'm doing them both together. So notice our formula setup. The first 3 fractions are the same. The only thing that changes is this last fraction right here, or conversion factor. Instead of having 22.4 liters on the top, we have 6.022 times 10 to the 23rd atoms of what we're trying to find on the top. Okay? This is the only new part. Let me get out of this. So again, here's my example. How many atoms of water are produced if you start with 4.12 grams of hydrogen gas? So again, guys, I'm really highlighting in these 3 conversion factors that everything stays the same. The only part that's changing is this last part, okay? So let's do an example together. Again, same reaction, but this is our question. How many atoms of tin are required to react completely with 31.9 grams of hydrogen fluoride? Okay. And this is just being slow. It's okay. So what is given to us in this problem? And what do we have to find? Remember, that's the first thing we have to do. So given to us, it's always a number, we have 31.9 grams of HF. And we're trying to find the atoms of tin. Okay, I've bolded those for a reason. So now that I know what I'm given and what I'm trying to find, I'm going to set this up. And we're going to give it a moment because it's going to take forever. But that's okay. It's really taken forever. Oh, come on. So, like I have always done, we're always going to start with what we're given. So we're starting with 31.9 grams HF over 1. Then we're going into our conversion where we have 1 mole of what we're given over the molar mass of that. So HF is about 20.01 grams for every 1 mole. And I only know that because hydrogen is 1.01 grams and fluorine is 19. So I did some simple math right there. Now we're going into our mole ratio. So we are going to have moles of what we're trying to find over the moles of what we're given. So we're trying to find tin, atoms of tin. So we're going to have moles of tin on the top, and we're going to have moles of HF on the bottom because that is what we're given. Remember where we get our numbers for our mole ratio from? The balanced equation. So what coefficient is in front of tin? What's that? A 1? You're right. What coefficient is in front of HF? Oh, I hear you over there. A 2. Okay. Last step. This is the new step. Whenever we're going to atoms, we're going to have Avogadro's number. So 6.022 times 10 to the 23rd atoms of what we're trying to find over 1 mole of what we're trying to find. And that's it. Okay? So I'll break this up for us again. Remember, when we're doing the math, the ones are irrelevant. We don't care about them. So we're going to do 31.9 times Avogadro's number to get us 1.921 times 10 to the 25th. Oh, that's not what I want. I've made a mistake, guys. There we go. And then we've multiplied everything on the top. We're going to multiply everything on the bottom. And I should be able to do this in my head, but it's a Friday. It's a long day. We're going to get 40.02 on the bottom. So now that we have multiplied the top, multiplied the bottom, it's time for us to divide. So our final answer, when we take 1.921 times 10 to the 25th and divide it by 40.02, we're going to get 4.80 times 10 to the 23rd. And our unit will be atoms of tin. And once I'm done doing that, I'm going to insert that, and that will be my example. So feel free to pause this video at any point, pause it, go back, really take your time to digest what's going on. If you do end up needing help with the atoms or the grams to atoms to grams, We're going to focus on that when I'm back in class, not today. Today in class, I want you to really focus on the liters and grams because that's a little easier. Okay, so thank you for watching this video, and I hope you finish your notes. It's not working. Here we go.